In this lesson, we're going to review everything we've learned so far in Chapter 4, which is all about division. So let's get started reviewing some division. I want you to divide 21 divided by 6. Tell me what the quotient is and what the remainder is. It might help if you draw a picture to solve this problem. When you divide 21 divided by 6, 21 is our total, it's our dividend, and we're splitting it into 6 equal groups. So sometimes pictures help us when we're dividing. We could model this division by drawing 6 circles and splitting 21 up evenly into those 6 groups. So I would separate those 21, 6, 12, 18, and then I'm at 18, and if I try and do 6 more, that's going to give me to 24, and I don't have 24, so then I'd have 18, 19, 20, 21, so I'd have 3 left over. So I would see how many do I have in each of my equal groups. I have 3, and my remainder would be 3. One way for me to check my work, or another way for me to think about this problem, is 6 times something gets me close to 21, but I can't go over. Well, 6 times 3, that other factor of 3, becomes my divisor. 6 times 3 gets me close to 21, but not over. 6 times 3 gets me to 18. And when I'm going from 18 to 21, I would have to add 3 more, which then becomes my remainder. So that's another way to think about division. Go ahead and solve this next problem, 43 divided by 5. I want to know what is my quotient and what is my remainder. For this problem, I might choose to think about multiplication to solve. So I would think 5 times what would get me close to 43, but I can't go over. I know that 5 times 7 gets me 35. I might list some multiples to see if I can get closer. I know that 5 times 8 gets me to 40. That's pretty close. But I also know that if I go 5 times 9, then I'm going to be over 43. So I can't do 5 times 9. So 5 times 7, I could cross that out. 5 times 8 is going to get me pretty close to 43. So my factor of 8 is going to be the number that's going to go in each of my groups. It's going to be my quotient. Now I need to think, if I'm multiplying 5 times 8, or I'm splitting 43 into 5 equal groups and 8 in each group, I need to know what's left over. In order for me to find what's left over, I need to count up, or I could subtract. So I'd have 43 as my total, and I'm going to take 40 of those away. Those 40 have been separated out evenly. And what do I have left? I have 3 left. So my quotient is 8, and my remainder to this problem is 3. Our next problem, we're going to use basic facts to help us divide. One of the things we talked about when we're using our basic facts to help us divide and when we use our compatible numbers is to underline those 2 greatest place values and think about, does our divisor go evenly into those numbers and how many times? So that's what I want you to think about when you're solving this problem. 270 divided by 9. If I underline my 2 greatest place values, I have 27, and then my divisor is 9. I know that I can split 27 into 9 equal groups, so now I have to think how many is going to be in each of those groups. 9 times what gets me 27? 9 times 3 gets me 27, and then I need to bring this 0 over here on over. So 270 divided by 9 gives me a quotient of 30. Next problem, do the same thing. I want to know what's the basic fact that you're dividing, and then divide to find your quotient. When you divide with this problem, we would underline our 2 greatest place values. So we have 36. Our divisor is 6, so we need to think 6 times what gets me 36, or 36 divided by 6 gets me what as my quotient? Well, 6 goes into 36 6 times, and then I'm going to take the 0 over here and place it at the end of my quotient. So my answer is 60. 360 split into 6 equal groups gives me 60 in each group. For this next problem, I want you to use compatible numbers to divide. So go ahead and figure out what compatible numbers are you going to use so that we can estimate our quotient. To do this, I'm going to underline my 2 greatest place values, and I have to think about my divisor. Does 4 go into 25 evenly? It does not, but I want to think about what it does go into evenly that's close to 25. 4 goes into 240 evenly. 4 also goes into 280 evenly. So these could be two compatible numbers that you could choose. And we would get two estimates if we divided these. I'd underline my basic facts. 4 goes into 24 6 times, and I would bring that 0 over. 4 goes into 28 7 times, and then I'd bring that 0 on over. So these are two different estimates that you could get for this division problem. An estimate of 60 as our quotient would be closer to our actual quotient than 280 or 70 as our quotient would be, because 240 is a lot closer to 251 than 280 is, but both of these are reasonable estimates. Let's go ahead and take a look at another problem. This problem says 365 divided by 7. For this problem, we want to do the same thing. We want to estimate the quotient using compatible numbers. So think about your 7 facts. 7 times what is going to get me close to 365? Or if you're breaking it down, we could just look at that 36. So what's going to get us close to 36 when we're multiplying times 7? And then list those two compatible facts. That's going to get you really close, and those are going to be two estimates for this problem. Go ahead and give that one a try. If I'm listing some compatible facts, I would think about my 7 facts. If I wasn't sure of some of my 7 facts, I could always list some multiples to help me. I know that 7 times 5 gets me 35, which is really close to 36. So that might be a compatible fact that I'm going to use. I'm going to take this product of 35, and because I have 36 here and I'm talking about my tens place, that would have 350, because this is going to be 35 tens. So 350 divided by 7, and I know that my 7 is going to go into that evenly because that is a basic fact here with multiplication. Now, because 350 is less than 365, I might try to go to a multiple that's higher than 7 times 5, so I'd go to 7 times 6. 7 times 6 gives me 42. That's greater than 365, and that could be another compatible fact. So I would have 420, or 42 tens, divided by 7, and I'd solve for these two basic facts using my compatible numbers. These two facts are going to give me an estimate of what my quotient is going to be between. When I solve these two problems, I'm going to see how many times does 7 go into 35? Well, because I listed my multiples over here, I see that 7 times 5 gives me 35. So I'm going to have 5 there, and then I'm going to bring this 0 on over. And then the same thing with 420 divided by 7. I see my basic fact here. I have my factor of 6. So 7 goes into 42 6 times, and I bring my 0 over. So my two estimates to this quotient would be 50 and 60. All right, here we have a word problem. Miss Ike ordered 2 pencils for each of her 49 students. Pencils come in packs of 8. How many packs of pencils does she need to order? Go ahead and think about this problem. This is a multi-step division problem, so we have to think about all of the steps that we need to take. Sometimes it's easier if we break this problem down and close our eyes, think about it as a story. What's happening in this story? I'm handing out pencils to 49 students. How many pencils is each student going to get? And then how many packs do I need to order? If I'm solving this problem, it's important for me to solve one step at a time. So I'm ordering 2 pencils for each of my 49 students. And I want to talk about packs of pencils. Well, in order for me to even start thinking about packs of pencils, I need to know how many pencils I'm ordering. In order to find out how many pencils I'm ordering, I'm going to have to do some multiplication. So if I'm setting up an equation for this problem, I would be multiplying first 2 times 49, and then I can divide by 8. So go ahead and do this, and I want to know how many packs of pencils am I going to order? What would my quotient be, and what would my remainder be? When I solve this problem, I could think about 2 times 50. 2 times 50 is going to get 100. Now 49 is 1 less than 50, so I'd have to subtract 2 out of 100. So I would have 98 divided by 8. And now I'd have to think of my 8 facts. 8 times what gets me close to 98 without going over? If I wasn't sure, I could always list multiples to help me. So I know that 8 times 10 is going to get me to 80. 8 times 11 is going to get me to 88. And I could keep going. 8 times 12, I would just add 8 more to 88. So that would get me to 96. And then 8 times 13, adding 8 more, is going to get me all the way to 104, which is too much. So just below 8 times 13, I have 8 times 12. This factor of 12 is going to become my quotient. Now I need to think, if 8 times 12 gets me 96, how many more do I need to add to get to 98? I need to add 2 more. So when I divided, after I multiplied, I divided by 8, and I got 12 remainder 2. Now I need to go back to my question. My question's asking me, how many packs of pencils does she need to order? How many packs of pencils do I need to order so that everybody gets 2 pencils? What type of problem is this? This is a quotient plus 1 problem. I need to make sure that everybody gets enough pencils. Right now, if I only ordered 12 packs of pencils, I would have 2 students or 2 pencils more that I would need. So I would have 1 student that wouldn't get any pencils. That poor student would be writing with something else. So we need to make sure that everybody gets what they need. In order for me to make sure everybody gets what they need, I would have to add another pack of pencils to my order. So I would need to order 13 packs of pencils. This is a quotient plus 1 problem because I want to make sure everybody gets what they need. I needed to order another pack. The next question says, Mr. Lassiter asked the 25 students in class to form groups of 3. How many students will not be in a group of 3? Go ahead and solve this problem. What type of problem is this? What would my quotient be? What would my remainder be? And then what would my answer to this question be? When we're setting up this problem, we would have 25 divided by 3. I can think in terms of multiplication. So 3 times what is going to get me close to 25, but I can't go over? Well, 3 times 8 gets me pretty close to 25. 3 times 8 gets me 24. If I'm at 24, I need to add 1 more to get to 25. So I have 8 remainder 1. I could also draw a picture to help me with this problem. Now, after I've solved my basic division fact, I need to go back and reread my problem and figure out what it's asking me. I want to know how many students will not be in a group of 3. If you drew a picture, you could have seen how many groups of 3 you had, and you would have had 8 groups of 3, or you would have had 3 groups of 8, either way. And then we would have this one little dot left over off to the side. That's what my question's asking me for. It wants to know what's left over. So this is asking me for the remainder. So this is going to be a use the remainder question. And how many students will not be in a group of 3? 1 student. That 1 student is left out and they are not in a group of 3. Here's our next question. Olivia has 70 beads to make bracelets. She puts 8 beads on each bracelet. How many full bracelets can she make? Go ahead and solve this problem. What is the quotient? What is the remainder? Then what is our question asking us? What type of question is it? And what is the answer to our question? If I'm setting up this question, I would have 70 divided by 8 because I want to know how many full bracelets she's going to be making. When I divide, I need to think about multiplication. 8 times what is going to get me close to 70 without going over? Well, I know that 8 times 6 gets me 48. 8 times 7 is 56. 8 times 8 is 64. But then 8 times 9 gets me to 72. 72 is way too much. So I have 8 times 8 gets me to 64. And then 64 plus what is going to get me to 70? I need to add 6 more to get to 70, so that's going to be my remainder. Now, if I was drawing a picture, I would have 8 bracelets with 8 beads on each of those bracelets. On my last bracelet though, I would only have 6 beads. Now my question says she puts 8 beads on each bracelet. So all of these bracelets right here have 8 beads on them, but this one only has 6. That one's not a full bracelet. So if I wanted to know how many full bracelets she can make, this is going to be a use the quotient problem. And when I identify the quotient in my problem, that's right here. So my quotient is 8, so I have 8 full bracelets. All right, let's take a look. We have 2 more problems to do. Our next problem says Ethan shares his birthday cake with his friends. The 16 slices of cake were shared with 9 people evenly. There wasn't any cake left over. How many pieces of cake did each person eat? Go ahead and solve this problem. What's your quotient? What's your remainder? Then what are we going to do with that information? How are we going to interpret the remainder of this problem? Well, if there were 16 slices of cake and we're sharing them evenly with 9 people, we would do some division. 9 times what gets me close to 16, but I can't go over? 9 times 1, and then I have a remainder of 7. Now my question's talking about them eating all of the cake. We don't want any cake left over. Right here with my answer, my quotient of 1 means everybody's going to get 1 full slice of cake, but then there are going to be 7 pieces left over, and I don't want any cake left over. In order to ensure that there's no cake left over, this is going to be a make a fraction problem. Now, in order to make my fraction, to figure out how much cake each person is going to eat, I have to think about what these different numbers represent. My 1 represents the total whole slices of cake that everybody's going to get. So everybody's going to get 1 whole slice of cake, and then everybody's going to get 7 ninths of another slice. My 7 came from my remainder. Those are the total pieces that are left over, and I'm going to split those total pieces into 9 sections. So everybody's going to get 1 7/9 slice of cake. We talked about how we're going to make a fraction when we have things that involve measurement, and then lots of times when we have things involving food, we can cut those things into smaller, even pieces. All right, last question that we're going to go over tonight. Lisa earned $585 after working for 5 weeks. How much money did she earn each week? We're going to assume that she earns the same amount every single week. Go ahead and solve this problem. How much is she going to earn each week? When I solve this problem, I'm going to have 585 divided by 5. Now, there are a few different ways that you can solve this problem. You could use the area model to solve, or you could use distributive property, whichever you prefer. I'm going to go ahead and I'm going to draw my area model to solve this problem. I'm going to have my 5 off to one side, and I'm going to take my whole of 585 and bring it off to the side. And now I'm going to start breaking that up. Well, I know that I can multiply 5 times something to get me 500, and that's going to take a big chunk out of this. 5 times 100 gets me 500. I'm going to go ahead and subtract that 500 from my total, and I'm left with 85. Now I have to think 5 times what gets me 85. I'm not ready to jump all the way up and get rid of all of that yet, but I do know that 5 times 10 gets me 50. That's going to take another pretty big chunk out of this number. So now I'm going to go ahead and I'm going to subtract 50, and I'm left with 35. Now I need to think 5 times what gets me to 35. 5 times 7 gets me 35. I'm going to subtract that last 35, and I'm left with 0 over here. All I have to do left to figure out what my quotient to this problem is add up all of my partial quotients on top of my rectangle. 100 plus 10 is 110, plus 7 more is 117. So she's going to earn $117 every single week. Now you could have broken this division problem up differently. This just depends on what you prefer. Our total answer here is $117 each week. Okay, that's a review for 4.1 through 4.6. Tomorrow we're going to go ahead and move on to 4.8, which is partial products. See you then.